or simply answering any question you may have for the previous chapters, what we discussed before. So we'll start now taking questions. What questions you have in the book. So please, if you have any question, just write question number, page number. Anyone has any question? Page 197. Page 197. Aisha, wait a second. Page 197. This is okay. All right. So this, what Aisha is asking is she's asking about this paragraph in page 197. Page 197, and this is about something called the resolution. And what does that mean? Resolution, as we said, as you have it in the slide, the resolution, which is simply separation of racemic mixture, is a challenge actually in organic chemistry. So how to do it? Normally, what we do it if we have a racemic mixture. Suppose we have a mixture of R and S of certain compound, of certain chiral compound, right? Then we make it to react with, let's say, one enantiomer of other chiral compound. Suppose other chiral compound. Suppose we take R. Now in this case, the R will react with the R and the R will react with the S. What's going to happen, we're going to get like R, suppose make it like this. Just imagine that the R here is like a triangle and the S here is like another triangle. So what we are going to get, this R connected to this triangle with the R. And this R will again be connected to this S with the R. Can you see it? You see? Here, what we are going to get, this is mixture or racemic mixture. We allow it to react with one enantiomer of certain compound. The result of the reaction will be this R reacting with this R reacting with this. So these are the two products. In general, this is what we are saying. Can you see it, Aisha? Now, these two now, the relationship between these two products, they are, as you can see, they are non-super images, so non-superimposable images. They are not images to each other. Therefore, what we can call these, we can call these as diastereomers. And therefore, these two can be separated then. This is simply the resolution. So in principle, the resolution here, it's allowing a racemic mixture to react with one single enantiomer of other compounds, which will produce a pair of diastereomers, and any two diastereomers, they have different physical properties, and thus they can be isolated or separated from each other. Is that clear, Aisha? Perfect. Any other question? Thank you. Any other question? Yes, this lecture will be posted or uploaded on YouTube. Any other question? Page 321, Aziza. Page 321. Are you sure about the page, Aziza? This page is in the carboxylic acid functional groups. So if you're talking about chapter 6, okay, it's 213, right. So page 213, please, all of you. Page 213, and the question is, question 6.42. I don't know, maybe you have different version, Aziza, or you please check again your question. This is not the correct page which I have. This is because I have the edition is edition 5. I don't know if you have edition 4 maybe. Anyway, I'll just check the question 6.42. What is the relationship between the specific rotation of 2R, 3R, whatever, and this between 2R and 2R, whatever? Okay. Anyway, yeah, okay. We will answer this question. So the question is, what's the relationship between the specific rotation of 2R, 3R, so we have two enantiomers, 2R, 3R dihydroxy pentane and 6.42 2R 2S3S 2S3S. All right, this is your question, Aziza, right? So this is the question. So what's the relationship between in the specific rotation of the two, which is simply the alpha D? Is this your question, Aziza? So then what's your question? This is what I have as 6.42. What version, what edition you have, Aziza? What's the edition of your book? Is it 4th or 5th? Oh, I see. That's why, actually, because I have the 5th edition book. Anyway, so yes, maybe if you can write the question or at least some hint of the question, maybe you can follow it up in the 5th edition then. Until Aziza writes her question, please proceed. If there is any other further question. Anyway, by all means, let's just discuss this question since we wrote it already. So what's the relationship with the specific rotation between these two compounds? As you can see, these two are enantiomers. So the relationship, if the alpha D of 2R, 3R has certain value, let's say, for example, plus 50, then the alpha D of the 2S, 3S must be what? The same value, but different or opposite direction. So it will be minus 50, that's it. Do you follow me? So what could be the relationship between, for example, 2R, 3R, and 2S, 3R? For example. All right. Can you see these? What's the relationship between these two? As you can see, since these are not the reverse completely, that means these two are diastereomers. then we can't say anything. This could be any value, this could be any value. We have no idea what they can be. The only thing what we can predict regarding the value of the specific rotation is for enantiomers. That simply one enantiomer will be plus certain value, the other enantiomer will be minus the same value. That's it, what we can predict for the specific rotation of any enantiomers. Now, any other question, please? And please, if you can, if you have it in the edition 5th, please, right away, because the same book what I have is the edition 5th. It's the same, that's better actually. Which page? Which page this should be in order to make it quick? 7.54. 7.54. And here is the board now clear? Maybe this way. Perfect. All right. Now, the question 7.54, the page is 241. Question 7.54, page 241. All right. Now, this question is predict the major alkene product from the following eliminations. So we have this. We have a methyl here, and then we have a bromine here, and then we allow this to react with KOH. Now, all right, Aziz, I will see it. Now, is this Al-Julanda, is this the question? Which one then? Do you have also Jalanda the number 4, the edition 4 also, or edition 5? What edition you have of the book? Oh, that's a problem actually, because I don't have the edition 4, I do have edition 5. So reaction of HBr with R3 methylhexanol. Reaction of HBr, R-methylhexanol. For 9. But you know, I don't have it. Actually, the book here, the edition what I have is edition 5 actually. Is not. Anyway, just let me see this. All right. Okay. I got to your question now, Wafa. So it's about drawing the Newman projection. Okay. So drawing Newman projection. Newman projection. Okay, and then reaction of HBr plus R 3-methyl hexanol yields racemic mixture. Bromo display. Right, okay. All right. Okay. I got both questions. Now. All right. So one question, I don't know the page, I don't know the question number, because as I said, there is conflict of editions. But anyway, you can just follow. The first question, which is drawing the Newman projection of 2R, for example, 3R, maybe 2,3-dihydroxypentane, 2,3-dihydroxypentane. Drawing Newman projection actually, this is, I think, Aziza. Aziza, is this a question now? Drawing Newman projection of 2R, 3R, 2,3-dihydroxypentane. Perfect. Okay, it's very simple now. Actually, all what we can do, we just, since we do have two stereocenters, we just draw it like this. And simply, what are the carbons? We have pentane. That means we have here an ethyl, and here we have a methyl. So what we have here, it's supposed to be, we have the opposite option, the different options. You have here OH, hydrogen, hydrogen. We can start all of them, drawing all of them first, and then simply determine the absolute configuration. So for example here, what's the absolute configuration of this compound here? As you can see, when you determine it, it will be, just check one, it will be, so because this is 1, 2, 3, 4, 5. So the absolute configuration of carbon number 2, as you can see, it will be above, so it will be R. So this is R. And absolute configuration of 3, again, it will be, yes, it will be S. So this is 2R, this is S, 3S. So this is simply the 2R, 3S. Do you follow me? So I did draw any Newman projection. Just draw it as such. And then from that Newman projection, you can very simply go to the desired Newman projection what you want. So the book here asking us to draw the 2R, 3R. But what I found here, I found this Newman projection is 2R, 3S. So which means I need to just to make inversion around the stereocenter of that one, because here S, the 3 is S here, what I draw, but what's needed is the R. So the new one will be simply like this, the same like the above one, CH2, CH3, and then here, this here, the stereocenter around the 3, I need to make inversion of configuration. Now this must be definitely 2R, 3R. Aziza, did you get how we draw it? Oh, and this is of course for all. Whenever you are asked to draw Newman projection of specific compound, all what you can do, just draw any Newman projection, any without specification. Then you simply determine the absolute configuration of the stereocenters what you have. If you find the stereocenters what you have is exactly like the required, great. If not, then make inversion of any stereocenter, which that means always when you invert, when you replace the two atoms around one stereocenter, you will get definitely the other absolute configuration. Clear now, Aziza and everyone? All right. For the other question about reaction of HBr, so I'm just going to erase all of this. I'm just going to answer the other question, which is reaction of HBr with 3-methyl hexanol. So when we allow HBr to react with one stereocenter with 3-methyl hexanol, that means we have 1, 2, 3, 4, 5, 6. Sorry. 1, 2, 3. 3-methyl. And then 3-methyl hexanol is the same, right? I think this was the one, right? OH. So of course this will be the R, for example. So when we allow the, of course, in general, when we allowing ROH to react with HBr, we are going to get RBr. So alkyl halide, we are going to get it from the alcohol by reaction with hydrogen halide. In this case, why the stereochemistry has been changed. In other words, we started with R, then we end up with a racemic mixture of the two. We got racemic mixture of the two. We got R and S in an equivalent amount. It's actually, this can tell us something. Anyone has an idea what this can be? What can we conclude? For example, when we started with one absolute configuration, we ended up with racemic mixture. What this tell us? Any answer? Anyone? What this could tell us? Of course, we didn't actually go through the mechanism of this reaction. But anyway, because it's all about the mechanism of the reaction. The mechanism in here, it's first, regardless of the stereocenter here, when we allow this alcohol to react with HBr, the first step, it will be protonation of the oxygen in here. So what we are going to end up with, we are all going to get OH2 plus. Then the next step, it will be the loss of the water as water molecule. So what we end up with simply now, this carbocation. Do you follow me? We are now answering the question of Wafa. This is the reaction of HBr. Why the reaction of HBr with the alcohol here changed the stereochemistry of the reaction. So please wait a little bit until we finish this question together. Then we simply move to the next question. Is that clear? All right. Now, Wafa. You follow me now, Wafa, now? Now here, we have formed carbocation. The carbocation is planar. It is sp2 hybridized, and it is planar structure. What does that mean? It means that now when the Br attacks this carbocation, this is like planar here, it may attack from above the plane, and thus it will produce certain configuration, or it may attack from below the plane, and thus it will produce the mirror image of that configuration, which means we are going to produce the two enantiomers in same quantities, and that's actually what we call it, the racemic mixture. So although Al-Julanda, yes, Al-Julanda, sorry, Al-Julanda. although this is, this is the explanation, but we didn't go through the mechanism of the reaction of the HBr with the alcohol. All what I asked you to do, just to know how to convert or to prepare alkyl halides from the corresponding alcohol. But since you did ask, then we have no choice other than to answer your question. Is that clear, Al-Jalanda and everyone, please? Respond quickly, please, in order to use the time efficiently. Thank you. All right, any further question, please? Any other question? Anyone who has edition number 5, that will be very much easy actually to go through to the question page and the question number. Any question, guys? Now, Al-Jalanda, this is your question. What does that mean? Partial positive? Is this your question, Al-Jalanda? Partial means يعني بالعربي يعني جزئي. Partial means it's not the full charge, that this atom does not carry like +1, +2, +3. It carries just part of it, like 0.1, 0.2, maybe 0.01, 0.23. It's not full. This is what we mean by partial. Is this your question? Is it clear now? Perfect. Any other question? All right, 3-cyclohexene 1-ol. Aziza, 3-cyclohexene 1-ol. 3-cyclohexene 1-ol, when we write 3-cyclohexene 1-ol, means we have parent compound cyclohexane, we have alcohol at position 1, so we just number 1, 2, 3. That's actually the compound. What does that mean? Or drawing the structure of 3-cyclohexene 1-ol. The 3 here refers to the ene, and the 1 here for the ol. That's actually what we always we have to do, always like that. We have always to designate the location of any functional group present in the compound. As you can see, in this compound, we do have 2 functional groups. We have alcohol functionality, which we always add the suffix like ol, and then we have alkene functionality, and then we add the suffix of ene. So in order to distinguish this, so we have 2. That's why actually this 3 is for the ene and 1 for the ol. Clear? Is it clear, Aziza? Perfect. Any other question? Any further questions? I will erase the board until I get some more questions. Two, 4, 9, 7.5. 249. Ma'athar, again, it looks like you have edition 4, right? Unfortunately, I have edition 5, so if you can please just make a picture of this question and send it to me by WhatsApp. I will just check it up as soon as I get it. Thank you. Looks like most of you have edition 4. Maybe I am the only one actually which I have who has edition 5. Anyone has edition 5 of the book? Aromatic synthesis. I will check it up. So I will turn the picture, stop the picturing until I get it. Just a second. All right. All right. Regarding your question, Ma'athir, and then we'll come back to Al-Jalil question for the aromatic synthesis. Now, for Ma'athir question is about, I think, in chapter 7 here. All right. For the question, the question of Ma'athir, simply if we have this compound, what would be the product? In presence of KRH. And if we have, for example, CBr, then we have CH, then we have CH3, and then we allow this to react with acetic acid, CH3, COO, H, in presence of H plus. What would be the product of the reaction? Is it? Yeah, okay. Now, in this case here, so we are answering now a question of Ma'athir. Now, in here, as we said, this is base, and this is secondary alkyl halide. So, what would be the major product we should expect for this reaction, Ma'athir, if we want to solve this reaction? Now we have a base. The most likely the behavior here will be base. It's not nucleophile because simply we have the negative charge on a small atom which is oxygen, which is not stabilized. So therefore we should expect it to be as a base behavior. And this is secondary alkyl halide. Secondary alkyl halide with a base. What would be the major reaction product in this case? Ma'athir or anyone else? What should it be? Yes, elimination, of course, but simply this is actually what we call it E2 elimination. Elimination via E2. Yes, of course. Yeah, of course it will be alkene. Now the question is, how the alkene would proceed. Generally, remember that alkene always proceed, or most likely will give us the more substituted will be the major compound, more substituted, whenever we have different possibilities. You follow me? But here we have another factor actually, which we didn't actually explain, because simply we didn't go through the mechanism of E2. In the E2, one requirement for the E2, simply that the leaving halogen, leaving group, which is in this case the halogen, in this case the Br, and the hydrogen, which will be eliminated, they must be untied to each other, or periperpendicular, what we call it. They must be periperpendicular maybe I'll just write it like this way. I'll just draw it this way. Must be anti-configuration, let's say. Or in other words, they must be by as an angle, the angle between them is 180. This is actually a very important requirement for E2, although we didn't actually explain, to be honest, because as I told you, we did focus on the previous chapter, chapter 7, we did focus on SN1 and SN2, but when it comes to elimination, we didn't go through details of the mechanism of the elimination. So, and we'll stick to that. The details mechanism is not required from you, but this is just one option, requirement here for E2, that the halogen, the leaving group, and the hydrogen must be anti-periplanar structure or geometry. In other words, they must be trans to each other. Now, for the example, what we have here, we have a methyl here, I guess. I think methyl. Yes, we have a methyl here and we have a Br. Now, if you can check here, the Br, in this case here, what we have a hydrogen in this case. Hydrogen can be, yes, it's okay, it can be. In this case, what we are going to get, we are going just to get the Zaitsev product, and which is simply the more substituted one. Do you follow me? Because actually the hydrogen here, we have a hydrogen according to the Zaitsev, which can be eliminated with the bromine. Ma'atha, is it clear now? Okay. Regarding the, who has a question about the aromatic synthesis? I think aromatic synthesis. Al-Jalil. Al-Jalil, this synthesis, what you have sent in the WhatsApp, please wait until we finish the next chapter, because there is a reaction, what we needed, but we didn't discuss it before. What we call it the Grignard reaction. The Grignard reaction, we will discuss it in the next chapter, chapter 9, and then when we finish chapter 9, then we will include all this knowledge for that synthesis. Is that clear? So we will answer your question when we finish the next chapter, inshallah. I will remember it, inshallah. I will mention it. Any other question? Yeah, that's actually to be honest, actually, with all of you, this is also the first experience to me to teach online. What we are going to do, we are going to make a typical exam like what we used to do, but this will be online. Now there will be the time dedicated to solve the question. The exam will be 1 hour and 30 minutes, which means total 90 minutes. You will be given like a period of 6 hours on the Moodle, and during that time you will be allowed to simply enter the question, the model, and submit your exam on there. I'm working on it. As soon as I finish it, and I will let you know exactly. Most likely, inshallah, by Tuesday, things will be very clear regarding the shape and the form of the exam. Is that fine, Wafa? I will check because it's too long actually to leave it for one day. Maybe 6 hours would be fine. We'll see, Wafa. Of course, we will take into consideration all the difficulties what you face, and inshallah things will be fine. Don't worry, I will take care of all these comments about the bad connection, so things will be fine, don't worry. But Tuesday, inshallah, I'll inform you finally how it will look like, how is the shape and the form of our exam. Now let's just focus on the questions, guys. Is there any further question? Inshallah. Thank you, Wafa. Is there any other question? No question? All right. If there is no further question, I think how many? That's actually math. I cannot say it now because I didn't even write the exam yet. But I'll give you more information about general information about the exam on Tuesday by email, inshallah, or by the WhatsApp. What about it, Aisha? What about the assignment system? Okay. Tutorials, you mean on the Moodle, right? Okay, let me open up, Aziza, the assignment. Yeah, sure. I will do it, inshallah. Okay. You mean, Aziz, the second question of which is the nomenclature, the nomenclature of the compounds? Which question then, what you mean, Aziza? The third homework. Okay, let me just see. I'm just opening it up in my... About the synthesis, starting from the indicated starting material and using other organic or inorganic reactions show how you could perform the following synthesis. Is that, yes, okay, all right. Okay, now regarding the first question, it's a, you want me to solve both questions in the assignment? Anyway, you get actually the key of the assignment today, but anyway, you can see it like this. So we want to start from benzene. We want to prepare meta bromophenol. As you have discussed before, so as you can see here, for this question, right, okay. The second question in the synthesis, you mean starting from cyclopentane, how can we prepare methoxy cyclopentane? Is this your question? The first question, the first reaction, or the first question, or the second? Which one you want, Aziza? Second, all right. Okay, so as you can see here, it looks like ether synthesis here. So we want to prepare, starting from cyclopentane, we want to prepare this methoxy cyclopentane. Of course, as we have explained before, the only reaction which I have to do whenever I work with saturated hydrocarbon is halogenation. Nothing more, nothing less. I don't have any choice. So while I'm closing my eyes, I just do halogenation of the cyclopentane, then I got now bromocyclopentane. If I want to do now, if I want to allow this to react with OCH3 minus, then I may not get the product. Well, I may not get this, because most likely what I'm going to get elimination via E2, because this is simply base and this is secondary alkyl halide. So the best option actually, instead of doing this, first to convert this into alcohol. So I'm just going to draw the whole answer and then we can discuss it. So first, in order to convert this into alcohol, the best here to make elimination by reacting with, for example, heating it up with sodium hydroxide, I'm going to convert it into cyclopentene. Then hydration, H2O in presence of H+, I'm going to get the alcohol of the cyclopentane, which is cyclopentanol. Now, as soon as I have this alcohol, the cyclopentanol, I can react this with sodium, then I will convert this into alkoxide. Now, when I have this alkoxide and I allow it to react with CH3, Br for example, methyl alkyl halide, there is 100% possibility just for SN2 reaction, and it will simply produce the desired product, which is OCH3, because this here will attack here and this will leave. Do you follow me? This is actually the best synthesis of this problem. I know it's a elongated synthesis, but it's a challenging question. So I want you just to understand the difficulties and the disadvantages of both methods. Anyway, just to make the story short, you can see here, whenever you are asked to start up with any saturated hydrocarbon, the first reaction, directly you have to do it without asking yourself any question, just halogenation. As soon as you have this halogenation, I want to prepare ether, and the best ether just to make part of it alkoxide and the other part is alkyl halide. If you now, the best here is to convert this into alcohol and then convert it into alkoxide in order to allow it to react with less hindrance alkyl halide. That's actually the solution of this question. Clear, Aziza? Any question about it, Aziza? Sure. All right. I think 1 hour is enough for questions. So we'll stop now, and inshallah we'll see you next Tuesday for the new chapter. Thank you for your attendance, and see you next Tuesday inshallah.